Welcome back. In this video, we are going to solve a structural design problem that involves a cantilever beam design using the working stress method based on eStructural Design Taichi found on the App Store. Design a reinforced concrete cantilever beam using working stress method with span of 10 feet, assumed width of 10 inches, and a balanced depth. The beam carries a uniform load of 500 pounds per foot and a concentrated load of 6,000 pounds at the end portion of the beam. Design criteria as follows. Strength of concrete 3000 psi. Main bars 3/4 inch diameter bar grade 40. Stirrup bars 3/8 inch diameter bar grade 33. The beam carries a uniform load of 500 pounds per foot. We assume the self-weight of beam to be 271 pounds per foot, giving us a total uniform load of 771 pounds per foot. It also carries a 6,000 pounds concentrated load at the end tip of the beam. Enumerate input parameters in our design problem. CB1 for name of beam, 10 inches for width of beam, depth of beam unknown, length of beam 10 feet, main bars 3/4 inch diameter grade 40, stirrup bars 3/8 inch diameter grade 33, strength of concrete 3000 psi, total uniform load of 771 pounds per foot, and 6,000 pounds concentrated load. Solve the balance section properties given Fc prime equals 3000 psi, Fs equals 20,000 psi. We get N equals 9.289, K equals 0.385, J equals 0.872, and R equals 227. Proceed to solve for flexure and depth of beam. The moment from uniform load is 462,600 inch-pounds, while the moment from concentrated load is 720,000 inch-pounds. That gives us a total moment of 1,182,600 inch-pounds. The effective depth is 22.82 inches, and the total beam depth is 25.32 inches. Round up to 26 inches. Solve the area of steel given M equals 1,182,600, Fs equals 20,000, J equals 0.872, and D equals 23.5. We get 2.89 square inches. The number of tension bars from a 3/4 inch diameter bar is 7. The number of compression bars is 2. To test shear stress and bond stress, first solve for shear force, which equals to 13,710 pounds. Shear stress equals to 58.34 psi, less than 60.25 psi concrete capacity. For bond stress, the total circumference of bars is 16.52. Bond stress is equal to 40.50 psi, less than 350.54 psi concrete capacity. Since the shear stress is less than the concrete capacity, we proceed to maximum spacing of 8 inches. Our final stirrup spacing is 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 8 inches. For 3/4 inch diameter main bars, use half-inch diameter stiffener bars. The design results for our problem are as follows. Fc prime equals 3000 psi. Fs equals 20,000 psi. Beam size at 10 inches by 26 inches by 10 feet. Main bars at grade 40. At support, top bars 7 pieces 3/4 inch diameter bar. Stiffener bars 2 pieces half-inch diameter bars. Bottom bars 2 pieces 3/4 inch diameter bar. Stirrup of 2 legs at grade 33. 3/8 inch diameter bar spacing, 1 at 2 inches, 1 at 4 inches. one at 6 inches, rest at 8 inches. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.